All right, stats, this is the second half of section 9.3, which is the confidence interval section. That's usually part 2 of the video is the confidence interval. Part 1 of the video is either the p-value or critical value method. So confidence interval is not going to look any different than confidence interval of some of the others, just a different equation probably to use. So calculating error, we do the t of alpha over 2 using that t-chart, and then standard deviation and the square root of n. To calculate the error. We are doing the same example from the front side, so the actresses and actors data that we had before, and we went ahead with the spreadsheet or with Google Sheets and found the average for the differences. So these 5 data points here, after we subtracted them, found the average, found the standard deviation, so I copied those over here because we're going to use those. Now, the only difference with this problem here is on the front side, we did a 95% confidence interval, okay? And most of the time they have us use the same confidence interval on the back side. So we would be doing a 95 confidence interval on the back side, which would make it so that we should have the same conclusion. We would fail to reject, but this time they're saying, okay, what if we change that to be 90% instead, okay? So they're going to change that to 90%, and let's see. On the front side, we failed to reject. Let's see on this side if we actually end up rejecting this because it's a 90% confidence interval rather than a 95, okay, because it could make a difference. So our hypothesis from the front side, our null hypothesis, was that the averages, the average age for females and the average age for males were the same, right? And in some cases, females might have a higher or a lower age than males, just because males, we talked about how they age differently and that type of thing. So they'll hire males older, but they'll hire females have to be younger, okay? So this is what we're testing our hypothesis on. And then we just need to do our confidence interval, okay? So let's find the error, okay? And in this case, t of alpha over 2 is going to be a different t than we had on the front side. The t that we had on the front side was 2.776 that we put down here, okay? But this case, since we're doing a 90%, we'll have to look him up on the table again, okay? So 90%, and then degrees of freedom is still 4 again, because we had 5 data points, so degrees of freedom. So now instead of using this 2.776 number, we're going to use 2.132. So it's going to change it just a little bit. So 2.132, and then I need times, I can put that in parentheses if I need to, the standard deviation divided by the square root of n. So I put 14.65 and the square root of 5 on the bottom there, okay? And then we figure out what our error is. So the error, type that into your calculator, see what you get, 2.132 times 14.65 divided by the square root of 5. And I got for an error, I got a large error, 13.97 about was my error, okay? And then I want to construct the confidence interval, okay? So this guy right here, d bar minus the e is less than mu d is less than d bar plus the e. Now, mu d, what should he be in the middle there? This guy, we're going to always look for him being 0, okay? Because we want to see if 0 fits in between there. And mu d is the difference between the mu's. Well, if mu1 and mu2 are equal, their differences are going to be 0. So that's why we're looking for 0 living in between here, okay? So I want my d bar, which is negative 10.2. I'm going to subtract 13.97. And then I have negative 10.2 plus 13.97. Okay, and let's see what we get for my interval here if I simplify those. Negative 10.2 minus 13.97, and that's negative 24.17 is less than 0, which is less than, if I go to plus 3.77. Okay, so now, does 0 live in between those two? Yes, it does. So that means that I am going to fail to reject this guy, which is what we said on the front side. So in this particular case, it did not matter that we switched from a 95 to a 90% confidence level. Some cases it might flip my results. But in this case, since 0 lived in between there, we're saying that those are equal. So we're going to fail to reject the null hypothesis. Okay, which is going to go with our claim. Our claim is going to be valid again. We didn't write that down on this back side, but the claim went with the null hypothesis. So if we fail to reject the null hypothesis, that means we're saying the claim is good. Okay, and that means that actors and actresses have same average age according to this data. Okay, and again, given more data or different data, we might say differently. But according to this data that we have here, the actors and actresses really have about the same age. Okay, so there is that. That's what I have for you. Lots easier formulas for section 9.3 on the homework. So you should have 1 done, number 3A done, and number 5A done. Okay. Part B, I'm just going to have you do the confidence interval and use a 0.01 significance level, or which actually would be like what? I think that's how I test the difference between measurements from the two arms. What can be completed? This should be like a 98%, I think, because you'll have, no, it will be a 99%. It'll be a 99%. I don't know what I'm thinking. 99%. Okay, 99% confidence interval. So do that for part B. You're going to do the same thing for part B on number 3. Okay, so you'll need a confidence interval for that one. Okay, and you can just submit those 3 to me, and that's all you'll need to do.